Today we're still dividing square roots, and specifically we're still really focused on rationalizing the denominator. But I need to show you how this idea relates to factoring. So take a moment and remind yourself, what does x squared minus 4 factor into? Hopefully this is automatic by now. You know that this factors into x minus 2 times x plus 2. That means that these two things are related to one another. More importantly, the middle term does not exist in x squared minus 4. And this is an important idea for what we're doing today. I'm going to talk about it this way though, that if you have a minus b and multiply it by a plus b, you will always end up with a squared minus b squared. Or if we apply it to this, x minus 3, and multiply it times x plus 3, I hope by now you know automatically that this will have to be x squared minus 9. Because that's the idea that we're working with, this idea of difference of squares and how the products work. But I do want to take it one step further. The idea is not really different. But let's say we had 3 minus the square root of 2 times 3 plus the square root of 2. Well, hopefully you notice that this is just like the stuff on the left. This is just a minus b times a plus b, a certain form. And that this will have to be 3 squared minus the square root of 2 squared. But 3 squared is 9, and the square root of 2 squared is 2. So that happens to simplify to 7. The biggest step, though, is that you understand this, that when you multiply those kinds of things together, those difference of squares, you always get the first term squared minus the second term squared. Get that clear in your mind, because that's the idea that we're applying today. Let's apply it. And again, if you didn't understand that idea, you've got to set up a conference with me. Let's look at 4 over 4 plus the square root of 2. Now this is a problem because we have a square root in the denominator. And our method from the previous day won't work because we have a 2-term denominator. It's 4 plus root 2. We're adding things. So to rationalize this, we're still going to multiply by a form of 1. But we're going to multiply by 4 minus root 2 over 4 minus root 2. These two things have a name together. Notice they're the exact same thing with just different signs, plus and minus. These are called conjugate pairs. They're the exact same terms, but one is plus and the other is minus. And conjugate pairs are the secret to rationalizing this denominator. The numerator, since we're just distributing, would be 16 minus 4 root 2, because it's just 4 times 4 minus root 2, and I just distributed. The denominator, since that's difference of squares, would be 4 squared minus root 2 squared. We can take this all a little bit further. The numerator, these aren't like terms, so we would have to leave this alone. But the denominator becomes 16 minus 2, or just 14. So it would be 16 minus 4 root 2 over 14. And this is considered simplified because the square root doesn't simplify any further. We don't have a fraction in a square root, and we don't have a square root in a denominator. I'm going to have you practice one more like that. Why don't you practice this one? Please rationalize 2 over 2 plus root 3. So hit pause and try it yourself. Well, the conjugate pair here is 2 minus root 3. So that's what we're going to multiply numerator and denominator by. And when you do that, you're going to get 4 minus 2 root 3 in the numerator, because we just distributed. And the denominator, since it's difference of squares, would be 2 squared minus the square root of 3 squared. The numerator, those aren't like terms, so we can't combine them. We would just leave it. The denominator becomes 4 minus 3, or just 1. So it's 4 minus 2 root 3 over 1, although most people would not leave that as a fraction and would just write our final answer as 4 minus 2 root 3. If this didn't make sense, make sure you watch this again. If you're still lost, make sure you set up a meeting with me. We'll look at a couple more examples in the next video.